Okay. Problem 1207, unique number of occurrences. Given an array of integers ARR, return true if the number of occurrences of each value in the array is unique, or false otherwise. This sounds pretty simple. So we are given an array, and then we want to check if the number of times a particular number occurs is unique. So for example 1, we have input array equals an array 1, 2, 2, 1, 1, 3, and the output is true. So the value 1 has 3 occurrences, 2 has 2, and then 3 has 1. So no two values have the same number of occurrences. Example 2, we have an array of 1 and 2, and that's false because both 1 and 2 appear once. And then we have example 3, -3 comes 1, 2, 3 times, 0 is twice, 1 is 4, and then 10 once. I think I have all of those. Okay. So we want to loop for sure. So I think this would be hash map-ish. So we were going to create a dictionary for sure. And the dictionary was just keep track of, okay, so we can do a value and a key. So 1, and then we can, okay, so we can use like the value and then how many times it appears. So that would be the first loop. And then we need a way to keep track of that, if we've seen that number of occurrences before. And that can be a set, since a set is unique, and then we can append. I don't think we append into sets. We insert. So, and then we can probably return false. So if the number, after we insert, if the number appears in it again, then we can return false. Outside of that, we return true. Okay. We have a good working pseudocode. So first things first, what we want to do is create our dictionary. Occurrence map. Var occurrence map. So this will be a dictionary of int to int, because we want the value and the number of times that it appears, both of which are numbers. So we can do this, yes, do this, int, like so. And then the next thing we want to do is map through our array that was being passed to us. So we can do for I in array. And then we want to fill our map. So we can do occurrence, OCC, occurrence map. And then open close brackets. First thing we're passing in is our I, and then with the default will be 0. I think we need to increase it as well. So then we come out here, plus equals 1. Okay. So and then we need our set. We need to thin this out to be more. Need a way to do our set. Let's do the set up here. Oops. I meant to hit this. Our unique set. And this will just be a set of integers, obviously. So we can do this. And then it'll equal just an empty set for now, till we fill it up. So we have our loop to create our dictionary, our set, and so we are going to do another loop through our map to check in our set. Right? Do for I in our occurrence map, or CC occurrence. I think I spelled it wrong. For I in occurrence map, and then we want to do the same thing we did in the previous one, where we check if the value is inside of our set. So if our unique set contains I, then we return false. Yep. And then okay, so we can do, no, we don't want to return true in here. We need to populate our set too. So yeah, so we'll do our if statement, and then we will, if it goes through the if statement and it is true, we return false, but then if it's not true, then we append. Okay, no, it's going to be unique set append ri. Okay, and then we need to do our if statement. If unique set contains I, if unique set contains I, this is when we will return false. So that means that the unique value is not unique. It's already in the set. Okay, so we'll go through it. If our unique set contains I from the occurrence map, return false. If not, then we put it in the unique set, and then we'll just do that. since we don't want to, we're only returning one. It's either all the numbers are unique or they're not. So if this runs and all it does is append everything into the unique set, it means all the numbers are unique, so we can just return true. But then the minute it hits, we return false. Okay. So we go, this should work. Error type key cannot confirm to collections if unique set contains I. Int I cannot contain to the collection. For I and okay. Cannot confirm only concrete types that are structured in the form required contains where. Okay, since we're using this is a dictionary, so it's not count, I think it's values. This would be somewhere auto completion would have saved me. Set has no member append. You are 100% correct. Arrays append sets insert. We're putting it in there. And voila. So this is true. We have 3 1s, 2 2s, and 1 3. This is false because we have 1 1 and 1 2. And then this one is also true. Alright, so that was pretty good. Let's submit it and see if we pass all the test cases. Okay, not bad. I never believe it when it says 0. So let's go look at some solutions. Okay. This one is pretty similar. We have the same, but then they're using an array. Okay. Okay, this is using dictionary values and then putting that in a set and then comparing the two. Okay, let's look at one more. I normally like to read the ones that have a little bit of a write-up. Okay. Create a dictionary to store the frequency of appearances of an element. Then we can sort the dictionary and check adjacent items if there are any duplicates. Time complexity, creating the frequency dictionary ON. Sorting dictionary OM log M. Checking for duplicates in the sorted dictionary OM. Now to find the overall time complexity, we combine these steps. The total time complexity is ON for construction the frequency dictionary, OM log M for sorting the dictionary, OM for the loop checking for duplicate frequencies. So the overall time complexity is ON plus M log M. That is confusing. N is the size of the input array. M is the number of unique elements in the array. In the worst case where all the elements in the array are unique, M can be equal to N. So the time complexity becomes ON plus N log N. In the best case where all the elements are the same, M is just 1. And the time complexity is ON. Thus, the time complexity for the solution is O(n plus m log m, where n is the size of the input array and m is the number of unique elements in the array. So they create a dictionary and they loop through the array, and then they add, and then they sort the dictionary by checking if the value is less than the next value, and if it's equal, return false, else return true. Okay, so that is it for problem number 1207.